Okay, students, we're going to go into Chapter 9, which is your PACS fundamentals. So there's a lot of objectives. Make sure you're able to answer the objectives. Take a look at the key terms. Make sure you know the key terms. And there's quite a few of them. So the fundamentals of PACS. All of you are familiar with the PACS systems. When I started in radiology, there was no PACS system. So it was film library, and we're going to talk about the differences between the film library and working in an environment that has a PACS system, and to see the difference in the workflow. So PACS is very common now, and they consist of a digital acquisition. There's a digital or display workstation. There's storage devices where we archive all the images. There's components are interconnected through an intricate network. So there's a whole network that's involved, and we're going to take a look at those networks. So PACS is the electronic version of a film library. So it's how the radiologist is able to view and dictate the images. So here's a typical PACS design. So you have the archive server in the middle, you have the radiology information system, which is your RIS, you have an archive server there. Here's your web server where you can go out to different clients. We call these client servers. And you have the different imaging modalities. So the modalities feed into the archive server, and it goes to the radiologist workstation. It also goes into the RIS. Well, it communicates with the RIS. This goes back and forth. It goes to an archive, and then it also goes to the web server, which puts it out on little clients, thin clients. So PACS started in the 80s, and it served just for mainly ultrasound. So with the advanced modalities, it was really good for that. So mainly at large research institutions, and as time went on, vendors became more involved, and modality-specific proprietary systems were developed. So there was a need for standardization due to each one speaking a different language. So with that came the DICOM. So that was, the first version was in 1985, and it's universally accepted as a standard, so it's a standard language. So it laid the groundwork for future development in PACS. Now every modality in PACS communicates via DICOM. So the DICOM is the language in which it speaks. So each modality or each vendor and modality boasts DICOM capability. So they all say, oh, DICOM compatible, DICOM compatible. So each DICOM statement must be read carefully to determine the extent of the compatibility. So components of your PACS. So it can be broken into three different fundamental parts. So there's the image acquisition, which is here, where we actually are on the acquiring the image. There's your display workstations where we view the image, and then there's the archive servers where we store the image. So those are your three different components. So they're acquired, images are acquired in the digital format. So ultrasound is, computed tomography is, and MRI is acquired in the digital format. So now we have DR, digital radiography, which is also acquired in the digital format. So display workstations. So any computer used to view a digital image. So most intricate part of PACS, and it's used inside and out of the radiology department. So you'll see these up in ER, you'll see them in the ICU, you'll see them in doctor's offices. They're all over. So your display workstation receives images from the archive or various radiology modalities, and it presents the images for you to view. So the workstation has come some sort of PACS application software. So in this chapter, they're showing a lot of Siemens workstations. So you'll see the display stations are mainly Siemens. So some of you guys will recognize that. Application software allows a mirror image manipulation. So some have advanced software with more complex imaging processing capabilities, and we'll talk about that later on. So your archive server, so it's in the file room of the PACS typically. So it's what used to be the file room, I should say, or sometimes they have the servers locked up. Most of the time they have to have a double bolt system where for HIPAA has to be behind two different locked areas. So consists of a database server or image manager, short and long-term storage, and a workflow manager. So it's a central part of the PACS. It houses all the historic and the current data. So may almost serve as the central hub that receives all images before released. So the workflow. Okay, so how does the workflow happen in radiology? So it's how a process is done step by step, or how a task is completed. So how one completes an exam from order entry to transcribed report. So exact workflow is different in every radiology department, whether it's film-based or PACS-based. The workflow is totally different. So when we had film, so this is a film-based workflow. So the order would go in, the paper would be handed to the technologist, so the technologist would come get it. We'd perform the exam here, so that's us taking the image. Then here we'd process the image, we'd QC the image, we'd send it to the radiologist, we'd actually hang it on a view box like in our classroom. We'd hang it up for interpretation. The radiologist would dictate into a tape recorder, and then the tape would be sent to the transcribed report, and it would get transcribed by the transcriptionist. And then it would actually, the report would be sent back, the radiologist would sign it off, and we'd have to file it in the jacket where the films were kept. So very, very extensive process. So here, when we look at the PACS-based workflow, the order goes in, there's no longer this person here. We still perform the exam, we process the image, it goes straight to the radiologist, and most of the time they do voice recognition software where they can actually transcribe it there, and they can QC it and get the report out with a turnaround time that's really fast. When we did the film-based systems, it took up to a week to get a report. So with film-based workflow, most departments were designed for film and chemical processing. So there's pass boxes, remember what those look like? And there's multi-viewer light boxes line the walls. So eventually chemical processing time was decreased. So the used to be like a minute and a half, and we get it down to like 45 seconds, which was really fast. So the film-based workflow still, the process begins by entering the order into the RIS, and a requisition with the following information was generated. Always had this information on your slip. The patient name, the patient's hospital ID number, date of birth, ordering physician, exam ordered, and reason for the exam, and then the patient's chief complaint. So some things haven't changed. So the paper requisition was passed to the performing technologist. Technologist prepares the room and brings the patient back into the room. They verify the patient, and so they need to make sure that the right exam is being performed. And they critique the images once they've acquired the images. So they make copies if necessary and release them to the patient. The technologist gets the patient's file from the file room, which could take hours or days. So sometimes the files were kept off-site, which was called Iron Mountain. I'm sure you see their trucks driving around every once in a while. So Iron Mountain used to have to come, we call them with the patient's numbers, and they'd bring it to us within a day or two. So current films are hung on the multi-viewer or light box for the radiologist to read. Historic films must be hung for comparison. So sometimes if you're waiting for a chest x-ray from Iron Mountain, it could be 4 or 5 days that the chest is waiting to be read. So the radiologist reads the film and dictates a report into the dictation system. The multi-viewer light box is cleared of the films, so you'd have to go in and hang them. There's usually film library people that would take them down and file them back in the jacket and return it to the reading room. So the transcriptionist receives the recorded dictation and transcribes the report into the RIS. So this could be same day if it was rushed, but usually took a day or two. So then the radiologist reviews the report, makes corrections, and signs the report as final. The final report is printed and placed in the film jacket. A report is also sent to the ordering physician. We'd have couriers that would go take the reports, or we would fax them. The final report may come several days after the exam is complete. So with the PACS system, the workflow is different in the sense that it's so much faster. It's almost instantaneous, which is great. So we get the order via electronic work list. So we still verify the patient. The order is input into the RIS, and the RIS sends a message to the PACS to find all the historical data on that patient. So whether it's in short-term or long-term archives. So this eliminates the waiting of a film jacket, which is great. So the tech still prepares the room, retrieves the patient, acquires the patient history. So you still need to record it. You're going to record it in the comments section, or if you guys are on Epic or a different kind of medical record, you can log it within the patient's record. The technologist performs the exams. The images are processed, repeated if necessary, and sent to the appropriate PACS device. So the images are tagged with information from the RIS, so the historical image reports are available. If the patient's physician does not have access to electronic images, you can burn a CD or DVD. Sometimes we can even print paper copies for the patient to take, and we'll talk about that. The requisition is given to the radiologist, where he or she may pull the images from the work list. The radiologist may pull historical information on the patient also to compare. So the radiologist dictates the report. A lot of times, like I said, they have voice recognition software where it's instantaneous. They review the report, make corrections immediately, and sign it, and it's a final report. So this turnaround can be minutes, which is great. So the system architecture can be defined as hardware and software infrastructure of the computer system. So the PACS architecture consists of acquisition devices, storage, display workstations, and image management system. So the three common PACS architectures are the client or server-based, distributed systems, and web-based systems, and we'll cover them. So client or server-based systems, so images are sent to an archive server. Displayed workstation functions as a client of the archive server. So it accesses images based on a centralized work list. Person at the client chooses a name from the work list, and the archive server sends the image data to the client. The image data are only on the client while viewing. So most systems allow basic image manipulation at the client. Changes are saved on the archive server. So here you can see the different setups here. So the advantages of the client or server-based systems is any exam sent to the PACS is available anywhere without other interventions. So only one person can open a study with the intent to read it. Others who open the study receive a message that the study is open and being read. So it tells you that someone else is in it. There is no need to pull or send historical images to a particular workstation because the old studies are available with the new one on the archive. So the disadvantages of the client or server-based systems is the archive server is seen as a single point of failure. If the archive goes down, the entire system goes down, and no image movement can take place. So newly acquired images must remain on the modality until the archive is back up and can receive images again. So it creates a huge backlog. So the system is network dependent, so images fly back and forth between the archive and the workstations, so network can become bogged down. So if your archive server crashes and it comes back up, it's going to most likely crash again because it's got all these images from CT and MRI and ultrasound and everyone trying to send, and then it's trying to pull up old images. The system really can have some problems. So archive server handles many requests at once and can become bottlenecks. So if I'm looking at an image on a client or server-based system and the radiologist wants to read it, I have to sign out. So you have to call the person who's on it and tell them to get out of it so that they can read it. So if you left for the day and left that patient up on your monitor, the radiologist would not be able to read the study until it was closed out. So that created some problems using the system. So the distributed systems, are also known as distributed or standalone models. So acquisition modalities, sending images to a designated reading station and now possibly a review station. So in some systems, the images are sent from the modality to the archive server, and then the archive server distributes the images to the designated workstation. So the archive server handled a lot of it. So as you can see here, we have the CT and the MRI and how it all kind of flows together here. So reading station designations may be designed on a radiologist's reading preferences. So MRI can be sent to one station, so CT sent to another, or all sectional anatomy or neurological exams go to one workstation. So they decide where it's going to go. So this works well if you have a musculoskeletal, radiologist who only wants to read MRIs, so you can have that set up for them. So the problem, one of the problems is that when you have that, if you want them to look at another study, they actually have to get up and go to a different computer. So that was kind of a pain in the butt. Workstations can query and retrieve images from the archive. So all images are locally stored. Images are then sent to the archive server after the images have been read. So if you have a problem between the two, you could possibly lose all your images. Images remain on the local hard drive of the workstation until they are deleted by the user or system rules. So we found that we were filling up these workstations and we had to go through and manually delete these images. So the advantages of a distributed system is if the archive server goes down, local reading at the workstations is not interrupted, which is nice, but we're going to learn that the workstations, some of them don't have the image quality. So after archive comes back up, the images that have been changed and signed off are automatically forwarded to the archive server, which is really nice. The problem is it could be a day or two, so they're kind of stuck in a queue. So that was kind of a problem. PACS data is less likely to be lost because of multiple copies of various locations, and system is less dependent on the network for speed, which is good. User can work on one exam while the workstation is pulling and getting the next exam ready to be read. The workstation can fetch historical images based on rules set up by the user. Okay, so sorry about that. The disadvantages of the distributed work system. So personnel rely heavily on the system to perform image distribution correctly. So if this distribution is wrong, then prefetching of historical exams will be wrong. So each workstation has a different work list. Only one person at a time can work on this list. It can be inconvenient to read additional studies. So the radiologist would have to move from another workstation to read the images. So users must depend on the query and retrieve functions when non-scheduled exams arrive at the work station. So it is possible for two radiologists to be reading the same exam and not know until they try to start dictating. So that's where the paper comes in, and it's so important that you give it to the correct radiologist. So web-based systems. So web-based systems are similar to the client and the server systems. So the biggest difference is that the images and the application software are held centrally and load to the client display. Only the images are held at the archive. So the archive server handles it. So as you can see here, the archive server has it all coming in and sends it out to the web server as needed. So the advantages are the hardware at the client can be anything that will support an appropriate web browser. So this condition allows for greater flexibility with the hardware. This can also be a disadvantage because low-end PCs can be used and the image display monitors may not be able to support the diagnostic quality that we are acquiring. So the same applications can be used on-site and at home in teleradiology. So teleradiology, if you guys don't know, is reading images outside of the hospital. So many companies are out there, Nighthawk, and there's several of them that will StatRad read offsite. Disadvantages is the system functionality may be limited because of the software not being locally installed. So also the bandwidth of the network connections limit the amount of data that can be transmitted. So sometimes it can be very slow. If you have really high resolution images, it can take forever to transmit a study. Some programs are large and cannot be transmitted via the network. It'll actually crash the whole system. The network is the biggest obstacle to performance. So, display workstations. The most interactive part of the PACS, it consists of the monitor, the computer, the mouse, and the keyboard. The hardware and software fits the user's requirements, so whatever they need. So, the display workstations, so conventional film screen uses large view boxes. So we call them light boxes, view boxes. There's multi-viewer where they alternate, so it'll slide back. You have like 20 different plates that come up. With early PACS, radiologists thought they needed 4 to 6 monitors. Now radiologists have become a lot more comfortable, and it's dropped down to they usually have 2 monitors, so that's nice. The monitor is one of the most important elements. There's 2 types, and there's the cathode ray tube, the CRT, and the liquid crystal display, which is the LCD. CRT, they're heavy, they're big, it puts off a ton of heat. They're good because they're really bright, and you can look at it at a 45-degree angle and still be able to see the image no problem. The LCD, they've dropped in price and have improved in quality quite a bit. So in most of your departments, you have the LCD monitors because of the size and the resolution and the lack of heat, which is great. They also require less maintenance, and they're able to give off a lot of light. And they are really good when the light in the room is bright. You can still be able to see the image very well. So resolution and orientation of the monitors are factors in determining which type of monitor to be used. So most cross-sectional imaging is read out on a 1K square monitor. Most digital projection images are read on at least a 2K portrait monitor, and I'll show you the difference here. So here's your portrait, and here's your other. So these are 1K, 2K, depending on what we're looking at. So the number of pixels contained on a display is known as its resolution. So more pixels, the higher resolution, the more information that can be displayed. So resolution is also defined as the process or capability of distinguishing among individual parts of an image that are adjacent. So pixels are arranged in a matrix, which we've covered. So some common screen resolutions found on today's monitors. So there's 1K, 2K, 3K, 5K. So 5K are very expensive. It's usually what your radiologists are looking at. Some have 3K, but overall 5K. Medical displays are generally higher in quality than displays of other applications. So radiologists use the highest resolution monitors available. Mammo requires a 5K or 5 megapixel resolution. So cross-sectional imaging only requires a 1K monitor, and that's usually what you're looking at. All right. Workstations can be categorized by primary use. So there's primary reading stations for radiologists, review stations for referring physicians, and technologist QC stations, and image management stations for like people burning CDs and stuff. So each workstation has its main purpose and is placed strategically in the department for it. So workstations may be made up of different hardware depending on the demands and the needs of the user. So like your workstation will have a lot more on it than what the film library's computer will have. So the radiologist reading stations, so they're used by the radiologist for reading the films. So the stations have the highest quality hardware, including the best monitors. So they're looking at the images in high speed. They'll scroll through, which we'll talk about here pretty quick. So computer hardware used depends on the needs of the PACS vendor, but usually robust with little downtime. So the keyboard and the mouse can be customized to the needs of the department. So there's many different types. That's about all you need to know with that. So the physician review station, so is a step-down model of the radiologist reading station. So stations may have the same level of software, but may reduce some advanced functions. So when physicians come in to look at images, we typically don't give them all the bells and whistles that a radiologist has. And sometimes they have the same stuff that we do, but we'll even take some of that off. We don't want them changing or manipulating the image. So one of the most important features is the ability to view current and previous reports. So we want to make sure that they can click on the report while they're looking at the images. So most referring physicians want to read the radiologist's report. Software may be loaded on a standalone station that is dedicated to viewing images. So software may be delivered over a web browser to any personal computer within the office or floor. High volume areas such as emergency departments and intensive care unit So those are great places to have physician review stations. It's important for the nurses to see also. So one of the greatest advantages of PACS is the ability to view the same set of images in multiple locations at one time. Okay, sorry, I have to keep taking breaks for my dog. The referring physician can pull up the patient's images in the office, which is really cool, and they can look at the report, and they can call the radiologist, and they can consult at the same time while both of them are looking at the images, which is great. So your QC stations, so we use those to look at the images before we send them to the radiologist. So when we're looking at these, we can improve some of the quality on it, but I don't recommend you doing that. So you can use it to verify the patient's demographics. And generally you have a 1K monitor. So when manipulating the images, technologists should be careful not to change the appearance too much from the original acquired image. So when you're changing, the window and level, it'll actually save that, and it limits what the radiologist is able to do when they manipulate the image. So they have it as a certain way on the lookup table. So when you send it, it may not look good on your computer on monitor, but when you send it and it goes onto their monitor, they're able to window and level it the way that they like to see it. So when you do it, you save it and you send it, the way you think it looks good is not necessarily the way the radiologist wants it. And when you do that, it changes it to where they have very limited window and leveling features. If you just leave it as it is, they can change it totally. So whereas when you do it, it limits them. So please don't change or save the window and level. Take it back to its original and then send it. So the QC workstations can also be used to query and retrieve historical images to check previous pathologies or body characteristics. So you can actually pull up a patient to see what they look like, you know, on the inside, so you have an idea what you're going to be doing. So the QC workstations can help with the selection of technical factors, so you can base it off of what was shot before. So the file room workstations, so before PACS, the file room was a large room filled with jackets, hundreds and hundreds of jackets. Today, it's as simple as several computers, and we have a dry laser to make copies, and there's usually a scanner. So this here, we have a scanner so we can scan in films that the patient brings in, and we can upload it into the PACS system, which is nice. So many hospitals are moving away from print films because of the cost. It's very expensive. They're moving towards burning CDs. So CDs are less expensive, can be made within a couple minutes, and they're easy to use. Software is burned onto them so that they can view it from any PC. So it's DICOM images with a software package that allows them, patients to view it or doctors to view it. So patients' demographics can be corrected also on the file room workstation. Don't usually like it to get that far. You want to fix it before it gets that far. So common functions. So common functions found in the PACS workstation can be divided into 4 categories. So there's navigation functions, image manipulation and enhancement functions, image management functions, advanced workstation functions. So most are available on any level workstation except advanced functions, which are specific to different types of workstations, usually found in computed tomography. So your navigation functions. So use these to move through images. You can go through series, you can go through studies, and patients. So you can customize your work list so you can navigate these files. So modern PACS software conforms to the Windows look and feel. So you'll have the grab bars on the right hand side, and you can use the scroll on the mouse, and drop downs as needed. So the mouse is a useful navigation tool. So hanging protocols, so they're defined how a set of images will be displayed on the monitor. So users can customize the protocol for each modality. So CT exam is selected, 4 images can be viewed on each monitor. CR image is selected, it can be viewed as 1 image on each monitor. Protocols can also be set to show the previous exam on one monitor and the current exam on the other. So after being set, the most efficient study navigation is determined. So it's each doctor, when they log into the computer, has a hanging protocol. So it's important that they log in and that they set their hanging protocol. That way it's set for the way they like to view the images. So you can see here the 2-on-1, you've got 4-on-1, you have 9, and then you have current study, and then you have priors here. So it can be set up any different way, and it depends on the radiologist. On your workstations, we will also have these functions for you to view it. So study navigation. So a study in PACS is the current or previous exam being viewed. So study may consist of 2 or 3 single images, such as a case with projection radiography. So a study may contain several series of images, such as a case with MRI. So we'll run 4 or 5 sequences for each study. So images can be simply paged through with the scroll wheel or arrows. So images can run through in stacks. So this is what we call cine. So we can stack it, and then the doctor can just move the mouse up and down or use the scroll bar, and it will fly through the images really fast in like a cine, like a movie for the doctor, which is great. Okay, so many vendors provide icons, so pictures within the software that activate software functions, so you can move between patients and various studies. You can open up the next unread patient file on the work list. You can close by clicking on an icon and open a patient the same. You can customize it based on your workflow. So image manipulation enhancement functions. Many tools are available to change the appearance of the image. So the common ones are window width and window level. There's annotation, flip, rotate, pan, zoom, and magnify, and measurements. So you're probably familiar with a lot of these. You probably don't ever work with the measurements, but I'm going to show you what it is. So here, this is windowing, leveling. So it may be a default function on the left mouse. So if you click on the left mouse, it'll automatically go to the preset. So you can also hold down the button on the mouse and move it up and down to change the window and level. If you move it up and down or left or right, it'll adjust the window and level. So the width represents the range of gray values. So level represents the center value of the range. Kind of confusing the way that's worded. So a change in the window and the level appears to change the brightness and contrast of the image. Most PACS systems can annotate text or graphics on the image. So annotations are not to be used for your left and right sides. So your left and right markers, no. It cannot be used for that. So I know a lot of you guys, if your marker's cut off or whatever, you just go ahead and annotate it on. It's not going to hold up in court. So annotations are used to indicate prone or supine, 30 minutes, upright or flat. Do not annotate in the anatomy like this image is. So here they have the right marker on, it's in a good location, but then they annotated this external rotation, and it's right here in the chromium. So you need to take that and you need to move it so it's out of the patient's anatomy. So this is absolutely not okay. If you do this on a comp, I will pull your comp. So nothing in the anatomy. So the radiologist will place circles and arrows and stuff around areas that they want to point out to the referring doctor. So flip and rotate, you guys are probably familiar with this. So flip and rotate tool is used to orientate the image so it's hanging the proper way. So if you have your cassette upside down, you're able to flip it. The use of lead markers is important to ensure that the radiologist is reading the correct side. So digital R and L may not be upheld in court during a legal case because of the ability to mark anywhere on the image and flip and rotate the image into any layout on the screen. So when I tell you that I failed you on a comp because you didn't have your marker on, but you tell me you annotated your marker on, it's still not going to work. I will not accept it. So it is will not hold up in court if you do not have a lead marker on your film. Your film is not legally sound. So pan, zoom, and magnify. So you've probably done this. Usually the radiologist does this. It's good for you to do it to see if you have any quantum model. So magnify usually enlarges a square area of the image. The square can be moved around so you can see quickly if there's a fracture or if you have model. So pan and zoom functions are usually used together, so image is first zoomed up to the desired magnification, then you can pan so you can see all around the different areas. So here's a good example of the magnified area right here, and then you can move this up and down and to look at the growth plates there. So measurements, this is usually done by the radiologist, so we usually use the distance and the angle. So the distance, the size of the pixel is known as measurement, so the software has the ability to measure structures on the image based on this. So the angle can give you an angle measurement between two structures, so commonly used when reading the spine studies. So you can see here, this is a measurement right there. All right, another common measurement tool is the ROI, so the region of interest. So ROIs determine the pixel intensity of a certain area. So different tissues or fluids have different intensities in the pixels. So the radiologist uses this to determine whether it's a solid or it's fluid filled. So when we're looking at cysts, this is a great way for the radiologist to be able to tell. So it's going to give us what's called a Hounsfield unit. So the Hounsfield unit will tell us if it's solid or liquid, using the ROI. So patient's demographics can be modified at the technologist workstation, the reading station, and the file room station. So you need to catch it before it gets to the reading station or the file room station. So you make sure that the patient information and demographics is correct. If the demographics are not correct at the archive level, the images can be lost forever. So, or they'll have a duplicate file, which is not good. Changes should only be made when the information is absolutely known to be wrong. So if you are 100% know that that is incorrect, you can change it or have a super user change it. A lot of times they'll lock it so that you can't change the information. So there's also the query or retrieve icon. So you can put in the patient's last name or their ID number or their date of birth, and it'll actually find the patient for you, which is great. So CD burning, so it's a feature that's available. A lot of times you can send stuff to the CD burner or you can send them to the film library. It's a good idea to send them to the film library as they'll make sure that HIPAA is being followed. And copy and paste, that's not a function that's typically used. We'll go ahead when we use the copy and paste, we'll anonymize the images so that the patient information and demographics is removed, and then you can use them for teaching or PowerPoints or whatever you need. So hospitals have to retain the ability to print films for outside use. So a lot of hospitals are getting away from printing the films. It's, like I said, very expensive, and if it's going to be used for education, you can anonymize them and print them. A lot of them are going to paper, so my hospital went to paper copies where there's actually not even an option for them to have films. So workstations can be connected to paper printers for quick records that pop right into the chart. So when you're up in OR, you can actually print the ankle right there and put it in the, give it to the doctor for the chart, or bring it downstairs for the radiologist to mark up to give to the doctor. So advanced workstation functions. So there's usually on a specialty workstation or the radiologist workstation. QC stations sometimes have them. So there's the MPR, which is the multiplanar reconstruction, the MIPS, which is the maximum intensity projection or the minimum intensity projection. There's a volume rendering technique, and there's shaded surface display or stitching. So multiplanar reconstruction. MPR is of the most commonly used three-dimensional rendering techniques. So we use this in CT. We take a patient and we take the axial scans and we acquire the volume of tissues. So slices are then loaded into the MPR software and a reconstruction in another plane. So as you know, CT only scans an axial, and we'll take it and we'll put it in a coronal or a sagittal plane so that we can see better. So most common application is producing coronal or sagittal images off of the axials. So your MIPS, so a function is used to visualize vessels or air-filled structures. So if it's vessels compared to air-filled structures is depending on what we're going to set it at. So the function commonly performed after injection of contrast medium on CT and MRI studies. So contrast medium shows areas of strictures or blockages within the vessel. So you can see here those bright white spots is calcium. So volume rendering. So similar to the MIP, so a function allows user to assign colors based on the intensity of the tissue. So bone, contrast, and organs have various shades of colors. Function uses histogram type of graph to differentiate the various structures. So, okay, so shaded surface display. So using a threshold of pixel intensity values. So everything below the threshold is removed and everything under a threshold is removed. So we can pick and choose what we want to see. So everything above assigned color is shown in a three-dimensional projection or object. So you can see here, this is the three planes. So we have a sagittal, a coronal, and an axial, and we can make it into a 3D by removing the tissues. And you can see this person has a really bad calcaneal fracture. So stitching, I'm sure a lot of you guys have used the stitching when working in your department. Most of the time it's for scoliosis. You can do it for leg length also. So typically we had a 3-foot film with a grid on it. It was very heavy. So now you have a cassette that you run and it's scanned, and we can actually use the software to put it all together for the radiologist to read it as one. So here is stitching of a leg length. So here, instead of a 3-foot cassette, we're stitching together the different images. So image post-processing is regarded as an advanced function on your workstation. So there's edge enhancement, there's smoothing, and contrast enhancement. Typically these are preset for you. When you get into CT and MRI, we actually use these functions. So many other advanced workstation functions are available to be added to the PACS workstation. This is a growing field, and we typically take this function away from you, but if you have a lung chest x-ray that you want to see the actual lines within the chest a little bit better, you'll use an edge enhancement. If you have bone that's real rigid and you want to soften a little bit, you can put on a smoothing filter. So there's different things that you can do. All right, so here's your summary. So you're going to want to go through your summary and make sure that you understand everything completely. I know this is kind of a long PowerPoint, and I apologize. Important that you know what your PACS system is and how the basics of it work. We're going to go ahead and cover Chapter 10 also for this week. So, and that is your PACS archiving and peripherals. So study up.